So hello everyone, this is lecture 32 for the mathematical physics. In the last lecture we did up to here, and we saw the polar form of complex numbers and de Moivre's formula. Now in this lecture we will study the roots of a complex number. So what is the meaning of roots? So if we study about a real number like 1, then if you need to find the square root of 1, then you will get two values plus minus 1, because square of both will give you 1. Okay, so that's how you define the roots. So if you need to find cube root, then you will get 3 values. For 1 by 4 you will get 4 values. That's how if you need to find a roots of a complex number, so it will be just same. Okay, so we will get a general formula to find root of anything. Okay, any number, it can be complex or real. So what is the meaning of root? Just if there is this one, we have 2 or 3. Okay, just like take an example 3. Now you need to find the square root, you will take 1 by 2. So you will get 2 such values whose squares will give you 3 again. And if you need to find the cube root of 3, then you will get 3 such values whose cubes will give you 3 again. And same if you need to find the 1 by 4 root, then you will get 4 values whose 1/4 power will give you this again 3. So that's how we define the roots. So if z equal to w to the power n, okay, means now n will came this side, so 1 upon nth root of z will be n values of w. Okay, for n equal to 1 you will get 1 value of w which correspond to z. For n equal to 2 you will get 2 values of w which will correspond to z, means w1 and w square will give you this again. And for z equal to 1 upon 3 you will get 3 such values whose cubes will give you z again. Okay, so that's how we define the roots. Then to each value of w there correspond to one value of z. Okay, means for if you are having two roots, then those two roots will give you z again after squaring, and if it is 3 then it will give you z again. So there are w means many number of values are possible which correspond to single value z. Okay, so those are the roots. So conversely, for each z is not equal to 0, there corresponds to n distinct value of z. Means n distinct value of w's are possible for single z, and those n values are roots of w. These are called nth root of z. Means for n equal to 1, their corresponding will be 1 only, so that will be one number. So we define w as root 1 by nth root of z. So for n equal to 1 you will get only one value, that will be w equal to z. For n equal to 2, means z to the power 1 upon 2, this is third. This n represents z to the power 1 upon n. So that will be give you 2 w values which will give you z again. So there are n number of w as possible for single z. Okay, and those n are roots of z. I tried my best to clear this, so hope it is clear to you. Otherwise you will understand with examples. So let's see some formulas. So let's define z with r cos theta plus I sin theta, and define w with r cos phi plus I sin phi. Okay, this is capital R, this is phi. Okay, now let's see what is w to the power n. It will give us rn, and using de Moivre's formula we will get cos n phi plus I sin n phi. Now z equal to w to the power n, means z should be equal to this. So let's compare, then we will get r equal to rn. And after comparing this we will get theta, means this n phi should be equal to theta plus 2k pi. Means this is the principal value of theta, but if we have another values, that will be theta plus 2k pi, means multiple of 2 pi. So this n phi will be equal to theta plus 2k pi. So z equal to wn, from this we find these relations, r equal to rn and r equal to this. From here this n will go this side, will give you 1 upon n. So 1 upon n can be written as n root r. Okay, this is third, means r to the power 1 upon n is this. Now n phi is theta plus 2k pi, where k correspond to 0, 1, 2, means it will go up to n minus 1. If n is 2, then it will go 0, 1. If n is 3, it will go 0, 1, 2, means up to n minus 1 k will go. So from here we find the value of phi, it will be theta plus 2k pi over n. Now we need the w, that is roots. Okay, so just substitute these values in this formula, this one. here. So here let's see, w is nothing but r cos phi plus I sin phi. So this r is nth root of r, and phi is from here theta plus 2k pi over n plus theta plus 2k pi over n sine, okay, I sin theta plus 2k pi over n. So this is our formula for w values. Okay, w is nothing but roots of this z, nth root. So for nth root you will put n value here, and you will find the values. Means let's say we have n equal to 2, we need to find the square root of z. Okay, so for n equal to 2 you will get k values as 0, 1. So you will put substitute n here, means 2 here. Then for k equal to 0 you will find one value, that will be one root, and for k equal to 1 you will get the other root, okay, for the n equal to 2. So that's how k vary from 0 to n minus 1. So if we need to find the cube root, then 1 by 3, so n will be 3 and k will be 0, 1, 2. So for 0 you will get one value, for 1 you will get one value, for 2 you will get one value. So all three will be roots, cube roots of z. So let's see, first let's see this definition. And these all roots which we are finding, they will lie on a circle, always lie on a circle, and when you join these points they will give you a polynomial of n edges, means n corners. So these n values lies on the circle whose radius is n root r. So this is the equation of circle. So this will be your radius, because magnitude of this will give you 1, so that's why this will be your radius, with center at the origin, and they constitute the vertices of a regular polygon of n sides. Okay, so we'll see this example in the next example about this polygon. So the value of w, that will be this, for k equal to 0 is called its principal value. For k equal to 0, whatever value you will get, this will call the principal root. Okay, so w is root. So for k equal to 0, the 1 by z, means z to the power 1 upon n, you will get principal value. So let's see some examples. Let's first find the roots of 1. So for z equal to 1, this is a real number, plus 0 iota you can take. So mod of z is r, that will be equal to 1. And first you need to find the principal value, that is theta, argument. So 1 will give you theta equal to 0, because it will lie on the x-axis, and theta will be 0 from here. So argument z will be 0. Formula is, this is z, this is n. So you need to find the square root first. So you will take this r n here, so it will give you 1 here. Cos theta plus 2k pi, so theta is 0, 2k pi over n is 2, so k will go 0 and 1. So first we will get this formula. Now put first k equal to 0, you will get cos 0 1, and this will give you 0, so you will get first root as 1 for k equal to 0. For k equal to 1 here, you will get cos pi will be minus 1, this will be 0 again. So second root will be, for k equal to 1, that will be minus 1. So you get these two roots for the z equal to 1, and if you try manually you will get the same values. When z is square equal to 1, then z should be plus minus 1, that's how you get. Okay. So these are the same values. Now let's see, find the cube root. So for 1 to the power 1 upon 3, you have the same formula, theta will be 0 for 1, so 2k pi over 3, and this. Now you will substitute k values. For 3, n equal to 3, it will be 0, 1, 2. For 0 you will get 1 again. For 1 you will get this value. For 2 you will get this value. Now see what is the meaning of these are the three roots, three cube roots of 1. Means cube of this will give you 1 again, cube of this will give you 1 again, cube of this will give you 1 again. So that is the meaning of cube roots. Okay, means 1 by 3 of z equal to this. Okay, now 1 by 3 will go to this side, will give you 3 power. So power of this 3 will give you 1 again. You can try by just multiplying this 3 times, you will get 1. Okay, now these all 3 points lies on a circle. We'll see about it. Let me show you. So first point is 1, so this will lie here. Now second point is minus 1 by 2 root 3 by 2, so it will be minus 1 by 2 here and plus root 3 by 2 here, so this point will lie here. And third one will be minus 1 by 2 minus root 3 by 2, so this will lie here. So now when you join these 3 points, it will give you a polygon, means triangle, and these all points will be on the circle of radius 1. Radius will be find it from here, z mod z will be r equal to 1. Now same for if you need to find the 1/4 root of 1, then you will get 4 values. Then again put the value here for 0, 1, 2, 3. So you will get these 4 values, 1 iota, -1, minus iota. Now we can denote these roots for 1 by omega, means 1 will be 1, first root will be omega, second will be omega square, third will be omega cube. Same here, first root will be 1, second called omega, third will be omega square. And sum of all these roots of 1 will always be 0. You can try, add these 3, you will get this will be cancelled out, this will give you -1 plus 1 will give you 0 again. Sum of all these roots will give you 0 again. So that's how the roots of unity defined. Okay, so these are used many times in the questions, so remember this property. Now these 4 points also lie on the circle of unit radius. You can see 1 will here, iota will be here, -1 will be here, and minus iota will be here. These all 4 points lie on the circle, and they make this polygon of vertices, 4 vertices. Now let's try to find roots for z equal to -1. So mod z will be again r equal to 1, and theta will be, you can see this -1 will lie here in this axis. So theta will give you, this will be your argument, that will be pi. So now theta plus 2k pi over n is first we need to find the square root, so n equal to 2. Now put k equal to 0, you will get first root. For k equal to 1, you will get second root. So iota and minus iota, these are the 2 roots for this. Now what is the meaning of root? Means square of this will give you -1. So iota square will give you -1, and this square will also give you -1. Now you can find the cube root. Again put n equal to 3 here, and k vary from 0, 1, 2, that will give you 3 roots. So these will be your 3 roots. Now in roots of -1 also, the sum of roots give you 0. Okay, you can take this sum, this will give you 0. You can take this sum, this will give you 0. Okay, so now you can find the same roots for z equal to iota. So mod z is again 1, so radius will be 1 for circle. Now theta can be find as this lie on the y-axis, so theta will be pi by 2, so argument is pi by 2, principal value. Now first we need to find the square root, so n will be 2, and theta plus 2k pi, theta is pi by 2. Now substitute k is equal to 0 and 1, you will get 2 roots. They will be this, 1 upon root 2 plus I by root 2. For k equal to 0, -1 by root 2 minus I by root 2 for k equal to 1. Same you can find the cube roots, so it will be theta plus 2k pi over 3, and substitute k values from 0 to 2, 0, 1, 2, you will get 3 roots. So these will be your 3 roots. Now same you can find for the z equal to minus iota. I am giving these examples, you need to remember these results for minus iota, -1 and -1 plus 1. These results are very helpful. You don't need to solve them again and again, just remember these results, what are the roots up to cube roots. Okay, and the results, the sum will be 0. So let's see this. For z equal to -1 minus iota, so mod z will be 1 again, theta will be, now minus iota lies on the y-axis on the lower side, so it will give you this angle, so it will be minus pi by 2. So again using this formula, you can find for square root you will get these 2 values, for cube root you will get these 3 values, and they will all lie on the circle of unit radius. Now let's see one example which is different from these, means a general complex number. So we need to find the square root of this. So first we need to find the mod z, that will be under root 49 square of this, and that will give you 25. Okay, so this will be 25. Now for means square root of means this number, it will be under root r. So under root r will give you 5. Then cos, you will write theta plus. Now how you can find the theta? So this point lies, x is -7 and y is 24, this will lie somewhere here. So you need to find this angle. So first tan inverse y by x will give you this angle, then you just need to minus this angle from pi. So find this angle first, tan inverse 24 over 7, forget these signs. First find the tan inverse 24/7. Now this angle should be subtracted from pi because this whole angle is pi. So this will give you this value. And take all the values in radians. Find this value also in radian, then minus this value from 3.14. Then you will get theta will be 1.8534. Now you will just use this theta, cos theta plus 2k pi over 2, and theta will be this and k will be 0 first. So this will you will give you this theta by 2. Substitute this value and find the values of this, and take this always in the radians here. So this will give you for k equal to 0, first root will be 3 plus 4 iota. For k equal to 1, it will give you this value after solving. Okay, theta plus 2k by means theta plus 2 pi divided by 2. So you will get again pi plus theta by 2, then you will get minus theta by 2. So you can solve this. This is just a simple trigonometry. So for k equal to 1, you will get this value. Now substituting theta here, you will get minus 3 plus 4 iota. So these will be your two roots, means square root of this. Now if you try to square this, you will again get this value, and square of this will give you this again. So that is the meaning of square roots. Now you can take this example also. You need to find the cube root. This 3 denotes the cube root of this, not a multiplication. This is third. So mod r will be under root 1 plus 1, so it will give you 2. So under root 2 is mod z. Now theta is what? This is 1 and minus 1. So x is 1 and y is minus 1. It will lie somewhere here. Now find the tan inverse y over x. Forget signs. It will give you 45 degree. So it is minus 45 because it is lying in this quadrant. So theta will be minus pi by 4. Now use the formula n root r. So it will be, if you need to find the cube root, then it will be 1 upon 3 of r. So it will give you 2 to the power 1 upon 2 multiplied 1 upon 3. It will give you 2 to the power 1 upon 6 here. And theta will minus pi by 4. Use k equal to 0 first, then k equal to 1, then k equal to 2. You will get the 3 roots. And all 3 roots will give you again this value when you cube these roots. Okay. So that's all for today. Thank you everyone.